the topic is number of functions from A to B. So starting from the first function, that is constant function. Let us suppose fx equals to any constant. It means what? For any value of x, whatever the value of x I am taking from set A, then output is fixed, that is k. Let us suppose if k is y1, then all will be mapped with y1 only, like this. So in this way we can have one kind of function. Or second option is what? Ki suppose the value of k is y2, means what? Ki constant value is what? Y2. So every input will be, for every input we get output as what? Y2. So one more option is there. Likewise, if m elements are there in set B, so total number of m different constant function are possible. So plus 1 up to m times. So total number of function is m. So in case of constant function, the total number of function is equal to the number of element in set B. Always. This is one kind of function. Now next one is 1 function. Let us suppose a function is 1. So for 1 function, I am again just making a set. Let us suppose it is set A, it is set B, A and B. If there are elements like x1, x2, x3, x4, and suppose n elements are there. Likewise in set B, y1, y2, y3, ym is there. Now see, suppose number of element in set A, is greater than number of element in set B. Now I am going to discuss the number of 1 function. Number of 1 function. So in case of 1 function, as we know, for every input there might be a dedicated output. So if we take number of element in set A is greater than number of element in set B, then what will happen? If you pair every element with any other dedicated element in set B, so all of them will be consumed, but number of element is greater in set A, and hence many elements are there in set A will be left out, and hence for them there is no any vacant element or unmapped element is there in set B, and hence 1 function is not possible. To make the function possible, we have to pair the remaining item with the, again that we have to pair the element with the elements in set B which is already paired. Means what? It is no more 1. So for in case of 1, if NA greater than NB, then 1 function is not possible. Number of 1 function is 0, I can say. Second case is what? Suppose number of element in set A is equal to number of element in set B. NA equal to NB. What will happen? Then in this case, for every element there is specific one element belongs to set B. In this case, suppose if for n element, suppose for x1, if you are mapping x1 in with any one of element from B, then for x1 there are m number of options. So let us say NA equal to NB equal to R. So for x1 there are R number of possibility. Now to pair x2 with any one of element that is in set B, for x2 there are R minus 1 option left because 1 is already paired, that is no more available. And similarly for x3 there are R minus 2 number of element they are in set B. Likewise, finally the last one will have only one element there, so it will map directly. So total R factorial is what? The number of 1 function in case when number of elements in set A and set B are equal. Third and last case for 1 function is, suppose Third case is if number of element in A is less than number of element in B, what will happen? We can consider it कि suppose n number of persons are there, n number of chairs are there. Number of chairs are greater than number of person. Now we have to make arrangement so that one person can sit in a one chair. So how can we do? We can select n item out of m item, means we can select n chairs out of present n chairs, and after selection we can arrange the n persons in n chairs in factorial n ways. So this is also we can also write it MPN. So this is what formula for finding number of one function. This is total thing about number of one function. So we discussed number of constant function and number of one function.